Good morning. It's a real honour to be here, and I would just like to thank the Royal Academy and CAETS for choosing this as the topic for this event. It is a topic that is very dear to my heart. It's the reason I became an engineer. I didn't become an engineer because I liked taking things apart. I didn't become an engineer because I liked putting things together. I didn't become an engineer because I wanted to rebel against my father, who thought it was an unfit profession for a woman. I became an engineer because I liked creating things, and I wanted to make a positive difference to society. I wanted to do something useful. I didn't want to shuffle paper from one side of a desk to another. I liked drawing, I liked maths, I liked physics. But when I studied at Cambridge University, there were no people. It was all about technology. I filled my head with sums and equations and analysis, and it was only in my final year I took a paper which was entitled The Future of Engineering and Society. That decision set the course of my career. I went on to go and work in India. I then went to join Arup. And Arup I chose because it was founded, it's a global firm of about 12,000 people now, but it was founded by a philosopher. If you're interested, there's a very good exhibition at the V&A on Ove Arup, our founder. And he believed that engineering was for social purpose. That's what the point of engineering was. And that's been my guiding star throughout my career. In 10 years ago, I made a decision. I started my career working with some amazing architects, designing buildings, some of the greatest architects in the world. I went and lived in Hong Kong. I worked on the design of the Chet Blackhawk Airport. I worked on buildings in Japan, in Germany. But always what I wanted to do was to actually get to really tangible engineering that evidently helped people. In 1994, the Rwandan genocide happened in Central Africa. And I was then a member of a charity called REDAR, Registered Engineers for Disaster Relief, which had a standby army of engineers who could be deployed at short notice to go and help in post-disaster situations. I was in my 20s, but I'd been on many, many training courses at the weekends, and I had huge amounts of self-belief, and belief too in the people who'd sent me there. I saw engineering change lives. I saw engineers secure water sources so that hundreds of thousands of people living in refugee camps had access to water. I saw forests walk backwards as refugees chopped them down for firewood, and realized how fragile our relationship with our planet is. I saw convoys of trucks coming in and worked out how to fix the roads so they could actually travel a bit faster. There were lots of doctors out there. There were very few engineers. And I think that whole experience made a big impact on me, because it made me realize we don't celebrate engineers. We don't recognize what engineers do. We recognize much more what doctors do, because they fix us when we get sick. Well, my sober challenge to you today is we are creative people, but if we're going to engineer a better world, our starting point needs to be that we need to realize our world is just a little bit sick. The challenges facing society over the next 40 years, and I'm planning to be here for another 40 years, are poverty, urbanization, and climate change. 10 years ago, I decided I wanted to dedicate the rest of my career to tackling these challenges and tackling them in the parts of the world where they pose the greatest challenge, referred to as the Global South or emerging economies. It includes Africa, Latin America, Southeast Asia, many of the small island developing states. So I set up Arup International Development. I realized I couldn't do very much on my own. My biggest asset is the fact that I work for a firm and have access to 12,000 brilliant people. I decided to set up Arab International Development as a business because philanthropy is finite. The money runs out. And the role of donors is really, really important. But actually, the role of empowering people is more important. There's a lot of rhetoric in the development community about the role of the private sector. Well, the role of the private sector is to become central to development. For the last 10 years, I've been seeking out problems, finding partners, employing amazing, creative, and talented people, and trying to make a difference by sharing some of those experiences more widely. I think our first challenge, if we're going to engineer a better world, is to actually recognize the problems. What is it we want to engineer? The first, I think, is education. 59 million children have no access to primary education. What's even more horrifying is that 30 million of those, half of them, are in sub-Saharan Africa. And more than half of them are girls. If you travel in Africa or work in Africa, you can be in the most remote area and you see small children walking miles and miles and miles to school. That alone tells you how much education means to people. Families who have very little money save up every spare penny they have to spend on the education of their children. If we can't sort out primary education globally, we're failing to tackle poverty. This photograph was one of many I took in Mozambique. Mozambique is typical, unfortunately, of many countries, unusual perhaps in that it suffered so much internal conflict. It has a massive infrastructure deficit. There are deficits at the scale of 60,000 classrooms. At present, thanks to the international community and the efforts of a number of NGOs working in Mozambique, they're managing to build 2,000 classrooms a year. I don't think that's going to fix the problem. 60,000 classrooms actually isn't very much. When I was working in Sri Lanka for the UN after the tsunami in 2005, there were 120,000 homes lost as a result of the tsunami. And in the 6 months after that tsunami, we built 60,000 transitional shelters by getting 100 different implementing partners, ranging from small NGOs with only 6 people to large established organizations like Oxfam and Care International, to collaborate, to partner, and to have a shared vision that we could do it. But no engineers are involved in designing a national program in Mozambique to tackle the infrastructure deficit. It's all fragmented. I frequently cry when I look at this photo, so I'm not going to look at it. It's a photo of a school in Nepal. After the Nepal earthquake in April 2015, some 20,000 classrooms were destroyed and about the same number damaged. The week after the earthquake, the estimates were that 870,000 children had nowhere to go to school. The earthquake happened on a Saturday morning. I leave you to imagine what the situation would be if that earthquake had been on a Friday morning when all those children had been at school. The earthquake in Italy last week resulted in the same situation. Hurricane Haiyan in the Philippines a few years ago resulted in 1.4 million kids not being able to go to school, and the floods in Malawi last year, 350,000. Part of this is the legacy of the Millennium Development Goals, where the focus was solely on the number of people, getting lots and lots of people to go to school, with not enough thought being given to the quality of the buildings that they were staying in. And if a roof blows off a school because of a hurricane, the challenge is not putting the roof back on, it's actually getting the money from government to put the roof back on. So a simple repair can actually cost school years, not days or weeks. This is a program that the World Bank are tackling. It's a multi-donor program called the Global Program for Safe Schools. And we've been working with them now for 4 years, trying to understand the systemic issues in countries globally, which actually contribute to the fact that we're building too few classrooms and too few good quality classrooms. Quality education is number 4 in the Sustainable Development Goals. And when they were published last year, I was delighted to see 2 things. Firstly, that they recognize the need for early years education. Very many of you have children and grandchildren, I suspect, possibly a few great-grandchildren. We all know that kids love to learn through play. We all know they're very small. We send them to kindergartens that are colourful, where they have access to things that will start their education early. But in Africa, very few people have that opportunity because they don't even have that opportunity at primary school. But it's there in the Sustainable Development Goals. But that's going to require a whole new infrastructure of kindergartens. The SDG also talks about the need to upgrade schools and build schools that are gender sensitive and provide safe, non-violent, inclusive and effective learning environments. In Ghana, we've been working for about 8 years now with the Ghana Trust, Sabre Trust, a Ghanaian charity who is promoting early years education. They spotted the opportunity because the Ministry of Education in Ghana said that they had an aspiration for all children in Ghana to have access to early years education. The people who run that charity know everything there is about education. They know so much about early years education, they realized they couldn't do it under a tree or in the type of building I showed you previously. They needed good quality buildings. And we've been working with them to actually design an appropriate design for kindergartens in Africa. 10 years ago, I was working here in the UK on the Future Schools programme and the Academies programme. And we were designing schools of the future and academies, secondary schools, for the performance standards that are set by the British government. They're very prescriptive in terms of the amount of air changes to make sure kids have enough oxygen, the temperature in the room so they don't fall to sleep, the acoustics so they can hear the teacher. But actually, if you think about a typical school in Africa, it tends to be made out of concrete breeze blocks with a tin roof and very little daylight. It's freezing in the morning. It's boiling hot by lunchtime. And when it rains, the sound of the rain on the roof means it's impossible to teach. If we're going to change education in Africa, we've got to come up with prototype classrooms, invest in engineering classrooms, changing classrooms from being non-engineered to engineered buildings that are designed. And they're designed and thought about, and so that all the excess is designed out. And what's left is something elegant, built of local materials, that is colourful, that's playful, and that has been built and has a sense of ownership by the local community. So far, 6 of these schools have been built. There are another 4 currently under construction. We've taken this model to Malawi also, and it's the preferred design by, one of the preferred designs by the government, and they're using it to train teachers, and 720 teachers have been trained over the last few years. That's scale, but it's small scale. The big scale is if the idea of actually having a model school that has engineering design investment in it and that is cost effective, this is no more than a typical African school, then scale will be achieved. Water is perhaps the biggest issue for the engineering community to tackle. 1 billion people do not have access to safe or reliable drinking water. That's just so basic, and yet it's something that we haven't managed to solve. This picture is of a project in the Maldives, where we were trying to solve that problem for a small island with a population of about 2,500 people that was rapidly growing, and where they had shifted from using the limited water source in the aquifer. They'd used rainwater harvesting. They'd then got reverse osmosis plants, technology solution after technology solution after technology solution. And what we proposed was a slightly different approach. It was integrated resource water management for small island developing nations. Now, if you look at integrated resource water management, it's a very well-established field. But all the theory actually comes assuming that you've got a catchment area on land, a large catchment area generally coming from the mountains down the rivers. And that's the basis of it. But actually, if you're in a small island, the catchment areas are very small, they're very different. You've got maybe fragile groundwater sources to be protected, rainwater supplies that are increasingly sporadic because of climate change. And you may be reliant on reverse osmosis, which makes you reliant on energy. So you have to think about the energy, and then you have to have a backup plan, and that's probably water tankers from somewhere else. So designing a water system in a small island developing state is not about pumps and taps. It's actually thinking about the whole water system and coming up with a way of thinking about infrastructure in the specific context which small island developing states epitomize. Increasingly, we talk about the importance of engineering for economic development. I'm part of a program which is a DFID program, which is actually all about infrastructure in cities for economic development. But the two things aren't engineering and the economic development. We need to work harder at articulating the linkages. This photograph is of a ready-made garment factory in Dhaka, in Bangladesh. We've been working there since the Rana Plaza collapse, which was a few years ago when a factory spontaneously collapsed. The previous couple of years, there had been disasters also because of industrial fires in these factories. So worker safety is at risk. The garment manufacturers who come from America and Europe, their household brands like Zara, got worried about this and formed a very unique alliance with the government of Bangladesh and these global garment manufacturers to actually tackle the issue of poor construction of factories and fire hazard and electrical hazard. There are around 3,000 factories in Bangladesh. Those 3,000 factories employ 3.5 million people. Most of those people are women. But the way this has been tackled to date has been using engineering technology, and it is very difficult to assess the quality of these factory buildings that are being built in a very haphazard way or adapted in a very difficult way. It's employed some of the best engineers I know to actually work out a methodology for how on earth do you go and assess those factories, and then to take that technology and make it possible for Bangladeshi engineers who have not had the same education as the people who designed that methodology to be able for them to assess it. And now for the factory owners to be able to identify the retrofitting that's needed and for that to be implemented. A bit like the schools in Mozambique, it requires a big national effort. But it's critically important because 70% of Bangladesh's exports are ready-made garments. We're not talking about the collapse of a factory. We're talking about what would happen if those ready-made garment manufacturers pulled out of Bangladesh or even reduced how much they rely on Bangladesh. That would have a huge economic impact and a huge social impact. Meanwhile, in Ethiopia, the ready-made garment industry is flourishing. There's a lot of investment going into Ethiopia. But the people advising the Ethiopian government tend to have economics backgrounds, and the engineers are nowhere to be seen. And so when you go and visit some of these ready-made garment factories as an engineer, you're looking for slightly different things. And you worry that they're being located in areas where there are high levels of water scarcity. And ready-made garments is a water-intensive industry. We need to find ways to get engineers at the top table and being part of the conversation. A great deal of my work over the last 10 years has focused on resilience, the word that is becoming ubiquitous throughout engineering, but also throughout society. It's not a very helpful word. I work all around the world, and it doesn't translate easily into other languages. But actually, we all know what it means. It means the ability to withstand, to adapt, to recover, but also potentially to transform in the face of disruption. We raise our children to be resilient because we don't know what the future holds for them. So we teach our children to have strong social networks, to be employable, to save money, to be healthy, to take exercise. All of these little things that we teach our children is what enables them to deal with the shocks and stresses that inevitably they're going to encounter in their lives. Thinking about resilient cities is the same. Cities are places of opportunity. They are places of innovation and prosperity. But they're also places where shocks occur and stresses build up. And increasingly, because of the concentration of people and assets in cities, those shocks and stresses are having a big impact. So when we're designing our cities and thinking about urban development, we need to actually be not just thinking about the positive future, but thinking about the uncertainty, and also recognizing the complexity of our cities. Can we really predict how an earthquake, a hurricane, a storm, a terrorist attack might play out? But I don't want to be too negative, because I actually believe resilience is a fantastically positive agenda. In London at the moment, we're celebrating the anniversary of the Great Fire of London. I say celebrating purposefully. It was a pivotal moment in London's development. It actually set a course where we thought about planning of our city, as was the plague, which made us think about solid waste management. So shocks and stresses are not necessarily bad things. It just depends what we choose to do about them. And I think we need to take a less defensive attitude and actually think about how we can learn from these things. Partnerships is the final Sustainable Development Goal. It's something that I'm completely passionate about. I don't think I can achieve very much on my own, but I think I can achieve a great deal by joining hands with others fighting for the same values. Those are the words of Ove Arup, my firm's founder, not my own words. But they ring very true, and they are being echoed in very much of what we read today, and notably in Goal 17 of the Sustainable Development Goals. What we've achieved over the last 10 years couldn't have been achieved without partnership. We've worked with the Rockefeller Foundation on their Asia Cities Climate Change Resilience Network initiative in Asia, where we were working in 10 cities, and that led on to developing the City Resilience Index. It's proliferated a whole lot of other relationships with organizations ranging from NGOs right the way through to international donors and other private sector organizations who, like us, want to make a difference. We're working with the World Bank on the global program for Save the Children. I'm about to go to Ghana this evening. The Cities Alliance is a very special collaboration of organizations that range from Slum and Shack Dwellers International right the way through to people like DFID and the World Bank. And the range and diversity of partners means the conversations actually really identify the problems so that engineers can actually get on with trying to help solve them. In Pakistan, we're working with IOM and several universities to try and re-engineer vernacular shelter in southern Pakistan, and the universities are creating the evidence base that actually might allow codes of practice to be developed. But above all, if we're going to tackle this issue at scale, engineering needs engineers. And they're not enough. There are apparently not enough in this country, and there are certainly not enough in Africa. That was pointed out by an excellent report that was done by the Royal Academy of Engineering in 2012. Roughly speaking, in the UK, for every 1,000 people, there is one engineer. In South Africa, for every 5,000 people, there is one engineer. In Mozambique, there is one engineer for every 100,000 people. In Ghana, it's approximately 10,000. So unless we can actually inspire engineers in these countries, invest in education in these countries, create partnerships with these countries to encourage the next generation of engineers, then we are going to be pushing a stone uphill. And as many people have mentioned, it's women especially who need to be encouraged to be engineers. As I said, my dad was not encouraging, but I carried on nonetheless. I've been lucky enough to have role models like Damon Dowling to follow, and I hope there is a chain of female engineers, including these two young ladies from Nepal, who will be following in my footsteps. But if we are going to educate the engineers of the future, I leave you with one last thought. What do they need to learn? It's certainly not the same stuff that I learnt at university. Because engineers now, when they're solving problems, these difficult, messy, complex problems, need not only to understand the technical parameters, but also the social and economic parameters, or at the very least, to be able to engage with other people who understand those parameters and work collaboratively with them. Thank you.